Load management is generally understood as the management of consumption with the aim of evenly distributing the load on necessary infrastructure. Load management is generally understood as the management of consumption with the aim of evenly distributing the load on necessary infrastructure. Because if peaks in consumption are eliminated, supply lines can be smaller in size and still provide a great benefit. This saves resources and is therefore much more sustainable. This idea of distributing load is present in all aspects of life. To give you an example, on our floor there is one printer for about 40 colleagues. If everyone wanted to print at once, there would be a jam. But that never happens. So that one printer, that's the infrastructure, is enough for all of us. Our natural demand takes care of the load automatically. In other areas, however, the load has to be controlled. For example, when charging several electric cars. Let me elaborate a little on that. Most electric cars can charge with 11 kilowatts AC. With 2, that's 22 kilowatts. Still fine. But now imagine that there are 50 EVs in an underground car park of a large apartment building. If they all used the full charging power, that would be 550 kilowatts alone. And that's not even including the other household consumers. Power supply lines of this size do not exist in standard buildings, and they are not necessary. Why? First, in real life, these 50 EVs are never at the charging station all at once. One is on vacation, the other is working late, the third is on a business trip. It's just like with our office printer. Second, in most cases, the maximum charging power is not required. The majority of cars are connected to the wallbox in the evening and stay there until the early hours of the morning. And during the night, there is enough time to charge more slowly, which means with less power. So with EVs, load management means managing the charging process. To prevent the building's electrical system from being overloaded, you can simply set a power cap for the charging stations. In other words, you are defining a fixed power limit. The wall boxes then just do not receive more power. This capped total power is distributed equally to all plugged-in vehicles. However, this is not real charging management, but simple static load distribution. The disadvantage of this solution, you basically never use the full potential of the building power supply. The charging power is always lower than it could be. Why? There must always be a safety buffer between the consumption of the building and the defined maximum charging power. Not so with dynamic load distribution. This is true charging management. Here, an intelligent charging infrastructure constantly communicates with the building's energy meter. The difference between the current building consumption and the building's maximum power input is then available to the wall boxes. This is usually less in the morning and towards evening, but considerably more at night, when the cars are usually drawing power. With our KEContact P30 X-Series wallbox, charging management becomes child's play. The charging station itself communicates with the building's energy meter and simultaneously controls up to 15 C-Series wallboxes. That's enough for smaller company and hotel car parks, parking or residential buildings. If you need more, there is our M20 load management controller. It can control up to 200 wallboxes, and that's enough even for the really big garage.